Okay, so here's another problem where we're going to find the effect in a structure at a point, in this case point C, for the shear created by a set of moving loads here, which is kind of a three-axle vehicle. So the first thing we need to do is draw our influence line for the shear at C, and there's C. So we're going to use Mueller-Breslau for our to get our qualitative shape. So we'll have a pin at A, a roller at B, and then we'll have this connection that allows shear, and we'll put positive shear on both sides. And how will this structure behave? Well, the left side, this 2-meter piece of it, right here at the connection, is it going to go up or down? It's going to go down. On the right side piece, this 6-meter piece, it's free to move here at this face. Since I'm pushing positive shear, this point at C is going to go up or down? Up, right? So you're going to get a shape that looks something like that. So if I transfer that down, I should be able to draw the influence line looks something like that. This will be 6 meters and this will be 2 meters. Now we can use the shortcut for this. We know a couple things. We know that this total change in shear as you go from left to right is 1. And we know these slopes are the same, so we have kind of a similar triangle thing going on here. So we know that this height is to 2 as this height is to 6. So this height must be 3 times bigger than this side, right? So if this is h and this is 3h and they have to add up to 1, what's h? You guys see that? So this side would be, say, h to 2. This would be 3h to 6. So really we have h plus 3h, and we know that has to be 1. So what's h? A quarter. So this would be minus a quarter, and this would be positive 3/4. So 1/4 is to 2, as 3/4 is to 6. And of course the change is 1. So we're done. Any questions about that? So now we're going to use this influence line with these moving loads as they go from left to right, and we're trying to find the maximum shear. So how many cases are we going to have? 3. Do you think the shear is going to be more maximum positive or negative? It seems to me the positive section of this curve is much, much larger than the negative section. So I think the positive value is going to be the maximum. So as I move from left to right, I'm going to let each one of my loads in turn hit the positive side, the 3/4 side, not the negative 1/4 side. So there should be 3 cases. So let's start with what I'll call case 1. So we'll have our influence line for the shear at C. Looks something like that. And we'll let our load slide over. So at the top will be the first load of 1 kilonewton, and then a meter back 4 kilonewtons, and then 3 meters back 6 kilonewtons. It looks like I should have drawn that a little bit bigger. So what are the values? Well, I know this one is 3/4. 1 meter back, what's this one? There's a couple different ways to solve this. I'll try this one a different way. First, I'll figure out the slope of this line. So the height over the run, so it's 3/4 high divided by 6. So that's 3 divided by 24, which is 1/8, right? That means for every meter I move to the right, I'll drop 1/8. So this is 6/8. If I move 1 meter over, I'll drop 1/8, so I'm down to 5/8. I move 3 more meters, I should drop 3/8, so I should be down to 2/8. I know that's really hard to see. I apologize for that. I should have drawn that. The next ones I'll draw a little bigger. Everybody see that? So now the shear at C for case 1 will be 1 kilonewton times 3/4 plus 4 kilonewtons times 5/8 plus 6 kilonewtons times 2/8. Is that? Yeah, 2/8. Is that right? No, that's 2. Yeah, 2. Yeah, 2/8. I need some help with that. I'm having trouble knocking that out in my head. This is 3/4, obviously. This will be 2.5. And what's that? 1.5. So that's 3, 4, 4 3/4. And that'll be kilonewtons. Oh, missed that. Okay, so the second case, I'll let the second load go to the top. In that case, that is the 4 kilonewton force. And then 3 meters back is the 6 kilonewton force. And of course, 1 meter forward is the 1 kilonewton force. So I've got to find a value here and here. What's the slope of this section of the curve? It looks like it's 1/4 divided by over 2, which is still an 8. So these slopes are the same. Except this one will also be dropping down. So if I move 1 meter forward, this is 3/4. This was minus 1/4. I move a meter forward, it'll be minus 1/8, right? 3 meters back will be a change of 3/8. So this is 6/8 minus 3/8 is 3/8. Everybody see that? Any questions about that? You guys want to discuss that? Okay. So then the second case, just apply those values. So I've got 1 kilonewton times negative 1/8 plus 4 kilonewtons times positive 3/4 plus 6 kilonewtons times 3/8. What's that equal to? 318. I don't know what that is. Somebody help me with that. What did you get, Mr. Kimmel?
5.125.
5.125? Anybody else get that? So that seems to be the controlling case right now. What happens when case 3, what do you think is going to happen? Think it'll improve it? Probably not. Let me drop this sheet over the top of it and we'll do case 3 real quick. So here's case 3. So we'll draw our influence line again. So now the rear wheel will be at the top. That's the 6 kilonewton force. 3 meters forward, and what happens? We're off the structure. And of course, 1 meter in front of that, we're also off the structure. So that's the only force that's on the structure. We know the height of that is 3/4, so this is easy. The shear at C for case 3 is 6 kilonewtons times 3/4, which is, what is that? 18 divided by 4 is 3.5? What is it? 4.5? And that is not the largest value. Yeah, so the maximum that we found at C is going to be 5.125 kilonewtons. And that will occur from this second case that we saw along the way. Any questions about that? Okay.